Um, Hello. Hi. So I'm going to introduce myself. I'm Pierre-Yves Ricau, and I work for Square. And I'm not going to go. I don't even have a slide about myself or my company. We do commerce. That's what we do. And so today I'm here to talk about our approach to crashes. It's somewhat specific to Android, but not actually that specific. So first of all, I want to talk about a special day for me. It was the 19th of April 2014. And there's nothing I'm not going to say anything really fascinating about that. It's just a day that I learned that a bug that I had been hunting for a whole year was now fixed. And we had finally managed to fix it. This bug had been in our code base for at least 2 years, and well, we fixed it 2 years later. So that was like a big relief. So what was this crash? It was just another one of those exceptions, a null pointer exception. Well, that's not what it's displaying here, but basically something was null. And well, I'm going to talk a bit more about this crash, and that's going to be kind of the story here, but don't worry, you're not here to listen about a crash for an hour. We'll have other things to talk about. So when we looked at the details, it was mostly a typical stack trace. If you've used Dagger, which is a dependency injection framework, you basically know that it creates a lot of extra stacks when it's doing stuff, when it's injecting all the things. So I couldn't put the whole stack trace up there. But yeah, that's pretty much it. Something was null. The really interesting part about this crash was that when you looked at the code and the line numbers on the crash report, and then you looked at the code of the specific version reported by the crash reporter, then the line numbers didn't match. So, and every single time I would look at a crash, for this specific crash, I would look at the line number where the exception was thrown, and I would look at the version number, and they didn't match. And that was crazy. I had never seen that. So my initial reaction, we were using Crashlytics to report crashes at the time. My initial reaction was to send an email to support saying, hey guys, your product is broken. You have a bug. Turns out they didn't. Android did, and I'll come back to that a little bit later. So yeah, let's take a step back. And ask ourselves a question. First, who has already written an Android app around here? So just, okay, pretty much everybody. So who's had a crash on Android before? Yeah, there's actually more people than... So what's a crash? From a user point of view, it's this weird dialogue telling you, hey, the app has stopped, and you can't do anything about it. Technically, what's happening is there is a thread somewhere running some code, and at some point you're throwing an exception. And that exception can be code, or it can go up the stack frames. And when it gets out of the run method of the running thread, then it is handled to the unquote exception handler, the default one. And so that's basically what's happening, although you never really see that code. And so what is this thing doing? It's basically handling the crash and doing something with it. What? Well, let's look at the code. Android is open source, and that's a great part of it. So we can look at what's actually happening. There's a class called runtime init. It has a main method, and from there, it's pretty much, an Android app is like any other Java app in a sense that there is a main, and when the app is started, main is called. And as part of the first thing that's done is installing a default exception handler. And this exception handler, it does two things. It logs the crash to logcat, so you can look at your logs. Great. That's very useful. And then it displays the dialog that we shows. It tells the system, hey, show the dialog, and then let me know when you're done, when the user clicked OK. And when that's done, it kills the process, which terminates the virtual machine, the whole process, and so the app actually dies. And then usually the system will restart it if the app was on the foreground. So there's no magic here. It's very simple, which means that you can actually replace the unclosed exception handler, and you can redo all of that code here. Or you could even not kill the process and let it go, which is so at DrawingCode London this year, I wasn't there, but I saw a slide. Well, actually, Jake Warren showed me slides from someone, and I don't want to call out anyone, so I'm not going to put any name out here. But there was a slide like this saying, oh, you can replace the unclosed exception handler with this kind of thing that is basically able to swallow crashes. So the app crashes and actually doesn't crash, and you continue, and don't do that. Don't do that. Please never ever do that. The reason you're having a crash is because there's a bug in your code and something crazy is happening. Why would you start, I don't know, the world is collapsing and you're like, no, that's fine, I'm gonna have a glass of wine and keep doing what I'm doing. No, just run. I don't know. Anyway, let's move on. So, why do we care about crashes? Maybe we don't. But then, try ignoring crashes. You'll release an app, and then you'll start getting bad reviews. That's like the first thing you get. People won't say, oh, you have a nice design, or it's very useful. They'll tell you, the app crashes, that's a piece of, and people can be nice in the user reviews, and even if they don't post that, you can actually, if you look at the numbers, a crash impacts user retention. So people will leave your app, and engagement, they will use it less basically because it crashes too much. And there's really a correlation between a crash and the user activity for some period of time after that crash. So how do we know that there are crashes happening in our apps? Maybe our app is perfect and we don't need to know because we know there's nothing, because we're good developers. Until you get bad reviews, and then you start wondering, maybe I missed something. So there is the other approach, which is, while you're in development, you're trying to look at crashes and then you fix them, and then you release the app and forget about it. So that's pretty much a mix between a wasteland and still the ideal world. Or you can use the Play Store. So on Android, the Play Store Android automatically reports crashes to the Play Store. The problem is that it asks for user permission before doing so. So the user sees a dialog saying, hey, do you want to send a crash report? And users, they're like 1 out of 10. Like maybe if it's a developer, it's going to be nice and going to be, okay, here's the crash information. But most of the time, this crash information does not actually map reality. Reality is this. Especially the first time you actually start looking into these things, you freak out because you have so many crashes. So the solution is to always send the crash information whatsoever, but anonymize it so that, because the reason the Play Store is asking for permission is because they don't want to send user data without the user agreeing to it. But if you're doing it yourself, it's your job to determine what is user data that shouldn't be shared with you and what is useful data. So that's pretty much what you do when you write your own handler. You store the crash information to the disk, you kill the process as usual, and you do the dialog thing too. And you do that actually by delegating to the default Android exception handler. That's great. The other thing you do is usually you would send when the app restarts, that's when you send the crash information. That's fantastic, but you want to do this kind of thing, but you don't want to actually write that code. It's not your job. Writing the client part would be easy. That's probably like a few hours of work. And then you're sending crashes to the server. And then what? How do you have a global view on everything that's happening? unless you're writing a crash, you're creating a crash reporting company, then I don't think you should spend any time on that because other people are doing it, and there are several competitors, and it's not perfect, but it's definitely better than what you want to spend time on. So this one is like the crash I was talking about on Crashlytics. So it has a ton of information, although here it doesn't have that much, but it's super useful. Yeah, so another one, so I just talked about Crashlytics, which is one of those tools. There's another one, which is Bugsnag. We stopped using Crashlytics a few months ago and started using Bugsnag for several reasons. And I don't want to start, like say, you should use this one or you should use that one. But that's what we're using right now. Another one is the open source project Accra. So this time, it provides the client library, and the server library is you basically download the code and host it yourself. And I haven't checked it recently, but it was pretty nice last time I looked at that. So let's say we install those libraries, we have a nice Crashlytics or Bugsnag or Accra account. What do? We discover that there are crashes, so we want to fix all the crashes. And it sounds like a great idea until you look at the numbers. Oh, I guess I have 200,000 crashes and 13K. So that's the number of crashes is the number of time it crashed. And the number of the left is the number of different stack traces. So you're looking at that and you're thinking, should I fix 13,000 different bugs? I guess the same kind of, no, I don't want to do that. The solution is easy, you obviously know it, you try to evaluate the impacts, and then you prioritize. And how do you prioritize? There are many ways. Usually, the easy way is the number of instances of the crash. But you have to relate that to the number of users it impacts. And we've seen sometimes crashes with one user crashing like 400 times. And you're thinking about this guy, this poor guy, he really wants to use your app. He keeps trying again and again and again, and it keeps crashing. But sadly for him, you have more important crashes to fix. So really, it's a question of ratio. It's like the raw number, the number of users impacted. But you might want to also do some more qualitative analysis on where exactly the crashes are happening. So Square is, we're doing commerce, and Square Register is our register application. So you have a payment flow where people, they pay with their card and all that. This is key, and this is very important because if it crashes, the merchant may lose a sale. But we also have screens with like settings or like some boring screens that really, if it crashes, it's bad, but they're not losing money. So that's how we prioritize these things. If money is involved, it's super important. Another thing that is kind of interesting, I've heard that several times. You're looking at crashes with people, and so you're like, oh, and this one, should we look at it? What do you think? And sometimes you see a stack trace, and at every layer in the stack, there is no package from you. There's it's only foreign code. It's Android code, it's some library code, it's Samsung code that nobody's ever seen, or and the reaction, the natural reaction is, this is not my problem, this is not my bug, I'm not gonna fix Android. So yeah, not my code, I don't care. Yeah, maybe. But think about your users. They're using the app. They don't care if it's Android or if it's Samsung or if it's I don't know. They don't care. They just say the app crashed. My experience is bad. The great thing, again, Android is open source, so you can look at the source. Maybe there is an Android bug, and you can report it and fix it. That's unlikely. It's more likely that you're using the API wrong, or some other kind of these categories of bugs where you try to do something and you gave the wrong parameters and it crashed later. It's probably your fault. So it's always worth looking into that. And even if it's not your fault, it's important to try to make your user's life better. Talking about custom ROMs, It's pretty much the same thing. And when I say custom ROMs, yeah, you're looking at the text trace and you're like, wait, I've never seen that code. You know, Android is open source, cool. But now I'm looking at something where I don't even know what that is. That applies to like manufacturers as well. A few years ago, it's not the case so much right now, but a few years ago, all of the major manufacturers would, you know, customize a lot of the Android code. So you would look at a stack trace and you'd be like, I don't know, this method doesn't exist. How do I fix the bug? There's no easy way, but really if users are impacted, you need to either install the ROM or buy the phone. We have, at Square, we have a device cabinet. We have like, I don't know, 400 phones. I don't know the actual number. I'm just making up a number. But we have a ton of phones. A lot of them are really bad, actually. But it's useful once in a while. You just go in there and look up for this crazy Japanese Disneyland phone with some weird, you know, like stuff you've never seen before. But because you have it, you can test it. And because people are using it, you want to fix the actual problem. So let's come back to our bug. So I talked about impact, and in that case, that was very interesting. When we released a new version, we would immediately, right after releasing, the next day, we would look at the numbers. So what crashes are happening on this new version? And this crash was like the top crasher. It was like, wow, so big, so many crashes. So we were impressed. But then we would wait a couple of days, and the crash would then be a top crasher. Like the number would, so when we would put a new release, we would see a lot of this crash, and then a few days after, you would still have some instances, but it would slow down a lot. That's really strange. So we figured it might be related in some way to updates, but it wasn't really clear. How does that, because nothing happens in your code when you update. Like the process, the app is dead, the code is replaced, and then it's starting again. So that's weird. So we talked about crashes, what they are, how we report them. Now, how do you measure crashes? So let's look again at those numbers. How do you measure that you're improving the situation, that the user who's getting the new version is actually going to have a better life than before? So an easy one is, well, just look at the raw number of like crashes. If it goes up, you're doing a bad job. If it goes down, you're doing a good job. The raw, like 200,000 crashes, this raw number is very tied to your success. If you have a lot of success. In a previous company, we got featured someday on the Android Play Store. Our crash rates, our crash numbers went crazy because all of a sudden we had, hundreds of thousands of people with different phones trying our app and running into code situations that nobody had ever run into before. So the number of crashes isn't really valuable. It's actually the ratio, like the more common value data is the ratio of crashes valued by the number of active users. That's good, but you can do better. When people try to look into that, usually you need to come up with a value that's related to what your business is doing. So for example, for Square, we look at the number of crash per transaction. We want it to be a very low percentage. The idea is that what matters in our app right now is people being able to make transactions. So we want to know the likeliness that doing a transaction will crash. So we built a tool that's like internal, that gives us for each version the crash rate, the number of crashes per transaction. And hopefully it's going to be lower and lower over time. Yeah. So now you just, you have an idea of how good you're doing. Are you making it better or making it worse? How do you avoid introducing new bugs, and how you overall try to make that number go down to the ground? You'll never fix all the bugs. We already saw that, but you can do a good job at improving it. So again. there is test. So you can try to test all the things, and that is a very good thing. I'm not saying you shouldn't test. We have a lot of unit tests and also instrumentation tests. The problem with crashes, it's slightly different. Crashes usually involve a lot of complexity. You're good, you're smart. When you write your code, you will know, you will see most of those things. Sorry, I'm thirsty. The mic situation makes this sounds interesting. I guess first, who write test, any kind of test? Good, but not, you can do better. It's important. And the problem is tests won't always help you with crashes because of the runtime situation of it, and it can be crazy conditions. So there's another easy way to take care of those crashes. For example, you have a null pointer exception. How do you fix it? Well, you check if the value is null, and then you try to find a way to work around it and say, okay, I'm backing off. I'm going to do something else. Do you think it's a good idea? I don't think so. Why? You're trying to recover from an unexpected state, which means when you wrote that code, you don't really know what's going on and what can happen. You're not writing good quality code. You're writing random code, like trying to protect yourself from some weird world. So we're doing payments, and imagine you're on the the person pass that you're paying with your card. You enter the card number, and then you're supposed to sign on the screen. And at that point, you're trying to get the card number, and you don't have one. So if you try to do something about that, it's scary because you should always have a card number there. And if you try to recover from that state, you don't know why you didn't get a card number in the first place. So you're pushing down the problem. Something even worse might happen after, and the payment may happen, may not happen. It's the worst for our users because they learn to expect that the app is going to behave crazily and randomly. So it's important to set your expectations in your code and crash fast. That's the title of this talk. So the idea was, crash fast. It's very simple, right? It's pretty much this. I'm finding a situation that I'm not expecting. Let's just throw an exception and let's let it kill the process. And yes, let it crash into the hands of our users, which you might not be comfortable with that, and I understand. It took me a while to understand this idea and why we were doing that. The idea is that, first of all, it's important that whenever a crash happens, because at some point there is a gap in what you think the code is doing and what it's actually doing. And usually, to make it easier to fix, you need to have the crash happen closer to the actual problem. So if you delay the crash by moving to something else and trying to do something else, then it might crash later. But in that later crash, you will have no clue why it's crashing. Whereas if you're crashing closer to the actual problem, then it's going to be way easier to fix. The impact of that, though, is that in the short term, you will be seeing an increase of crashes, and that's scary. And you're releasing something, and all of a sudden, a ton of users are seeing their phone crash. But think about the long term. In the long term, your code quality is going to be way better because when you're writing something, you know what you're dealing with. You know what are the inputs. You know why you're in this state. Also, you will catch a lot of these crashes in development while playing with the app. And overall, in the long term, it's going to mean less crashes and a better user experience. Also, it's really nice when you're in a code base. I mean, you've all seen that. You have two situations. One is I'm in a code base. I have no idea what's going on. Like maybe this is null. Maybe I'm calling get something, and maybe it's null again. And you're like checking for all the nulls. That's scary. You're not, you don't feel comfortable writing that code. It's so much easier to just know there's something or there's nothing. So the other thing is, as soon as you start doing these things, it's also very important to do progressive rollouts, even if you don't do these things, because progressive rollout is the idea that you deliver a new version of the app to a low number of users, and then you progressively increase that percentage. It's very nice. We do that for like 5%, and we look at the top 10 crashers, and we see if we can fix them, and then we do a dot release with just the fixes, and we increase the percentage. And that way, if there's like some, because we write so much assertions and we're very strong about how to, about what we expect in our code and we crash really fast, if there's anything major that we missed, at least, well, I guess 5% of the users might get into that situation. But we'll see it very fast and we'll look at that very closely. We have like alerts sending emails saying, hey, something bad is happening. Let's look into that. So another thing that's really interesting is, so now we know what's going on. We have, we're measuring how good we're doing. We're trying to work on doing fast crash. So now we have a crash. What can we do to make it easy to fix all of those crashes? Sometimes I wonder, like one of the things we don't do that, but sometimes I'm thinking we should have, when we interview people, we should ask them to fix crashes. Because to me, that's something that shows an ability to handle a great deal of complexity. You're dealing with, that's the basis of, computer science. You're having a hypothesis, and you test your hypothesis, and then you eliminate, and you try to do more, etc., etc. And I actually find that fascinating, trying to understand, getting in the situation where you understand exactly why this crash is happening. I think it's like, it makes me happy. But the key to doing that is to gather information. So the first piece of information, we all know that piece is the stack trace. I know this looks weird. This is how Crashlytics represents a stack trace. Some people like it, some don't. Anyway, so this is a stack trace. You'll notice an interesting bit. See how it is, like some of these lines are in gray and there's a blue diamond on the left. This blue diamond is basically, it's collapsing some part of the stack trace because Crashlytics is smart and thinks it knows the information you shouldn't have to look at because it's not important for you. Maybe in the future, someone will find the perfect version of that. Meanwhile, I've seen this on different tools, right? It's not just Crashlytics, but every tool that tries to do that, they only manage to hide very useful information because it might not be useful like 80% of the time, but when it is, sometimes you don't even realize that this diamond thing is here and you're missing like the first line or the last line and you're missing some key information. The other thing is, if you've been doing Java for a while, you're probably very used to reading stack traces, and it's like natural to you. It's like there are patterns, and you're scanning through it, and you know exactly where to look. So I don't think you need any sort of help here. So the stack trace is nice, but it's not always enough. Actually, most of the time, unless it's an obvious bug, like oh yeah, this can be null actually, and I should really check for that case. Most of the time, it's not enough, and it's even more true in client code, because on the client code, you have this main thread that is just a for loop that turns forever, that takes stuff out of a queue and execute it, and then you want to execute stuff on that main thread, so you post to that for loop, and as you do that, you're posting stuff to execute later. So if that stuff to execute later crashes in some way, you get a stack trace that starts at the dequeuing from the queue. But that stack trace doesn't include what happened and why you posted that thing to execute in the first place. And that makes it really hard because now you have something that happened, but you don't know why it happened. You don't know what originally led to it. On the server side, when you're handling HTTP requests, for example, it's much easier usually. Well, if you're in a single thread, request handling thing where you don't try to do asynchronous stuff. But if you're in a synchronous model, it's very easy because you see the request coming through and you're going through every stage. So it's very easy to understand the path. So the key to fixing a crash, and you obviously know that, it's being able to reproduce it. How do we reproduce a crash? You're looking at a stack trace, just code. How do I even reproduce that? The first thing is obviously to reproduce, you need information. So device details, that's pretty obvious, but you want to know everything about the phone on which it crashed. this is also, again, very useful for identifying patterns. If you have 10,000 instances of a crash, you're not going to look at every single one of them. But if you have something that tells you, well, it happens on Android 2 and Android 2.3, doesn't happen on this version, or it only happens in landscape, this crazy configuration, then you know you have something to work on. It's going to make it so much easier to reproduce the crash. Another thing that's very important, so the version number. When we're in dev and we have a crash, the version number is not enough, because usually on master you have a unique version number and then you keep working. So you want to know the SHA, the revision of your source code as well. So because you might be installing on a device and then someone else is taking it and trying something and it crashes, and then he's like, it's version 2. The line doesn't match. Well, and then you have to look at the SHA, and from the SHA you can actually know. From the revision and from the source tree, you can know where it happened. Another key piece of information, the user ID. So, I mentioned at the beginning that you don't want to send user information to the server. The user ID, well, we call that user token because it's different from our, internal user ID. You want to differentiate those things, basically a hashed version of it. But this user ID won't be useful every time, but sometimes you see a crash so crazy that you can't understand it. At the very least, you can use the user ID and get in touch with the person in some way. Like maybe they provided their email address, so you can look up their email address and then try to contact them and say, hey, what were you doing? What happened? There is also useless information. And sometimes you see like, oh yeah, cool, it had 50% of battery. Unless you're, I don't know, you're writing a battery saving app or something, I don't think that's very useful. So it's important to have quality information over quantity, right? The thing that one of the most useful things I find is what we call that, I think the OSNAP log. It's because OSNAP it's like, oh snap, the app crashed. But anyway, this is basically a navigation log. It's a high-level log, so in many different places in our app, when we go to a different screen or when we do a call to the server, we have these high-level logs. And we have a ring buffer of those logs so that you don't want them to grow up forever in memory. So let's say you have, I don't know, like a few thousand of those logs. And then, you push the new ones into it. So when the crash happens, you collect all that information and send it to the crash, to the server, to the crash reporter on the server. That way, when you look at a crash, a specific instance of a crash, you can look at the navigation log, and that's going to help you figure out where the user was, but also what he did. On Android, we have a lot of bugs, crashes related to rotating from portrait to landscape. This is the kind of stuff that show up here, and for me, it's like immediately I know, okay, this is again one of those rotations, and something's battery's gone with. It's happened to, like fragments and all that. So that's like the most useful thing we have. Another one that's very interesting, so that's basically history. You want to know history. The other one that's important is the current state. What is the app doing right now? One of these things, for example, that I wrote is something that goes through the view hierarchy and try to make a string representation of it. We didn't want to send a screenshot because screenshot may contain user information, and also it's a ton of data. But a string representation of the view hierarchy, it lets you understand, okay, so what was visible on that screen? Oh, like this view should be visible, but it's gone, or it's like out of the screen, it has the wrong size. Many things, and this is also very useful. We also use that as a dev tool. So because the code base is big, you don't know everything of it. So if you want to fix a bug somewhere, you just go on the screen and then you say, dump the view hierarchy to logcat. And so you can find the class names that are in there and the IDs, and from there you can like walk back into, okay, so this is actually the screen that I'm looking at. And finally, I talked about user information, which we call PII, which I don't even remember what it means. But so that's basically, PII is the information that is private to your users. and you do not want to share that, especially not with a third-party provider like Crashlytics or Bugsnag, because you are legally required to not share that with these providers. So it's important, for example, if you're going to have this navigation log and you're going to put some serialized stuff like, oh, I have this object, I'm going to put the JSON version of it, just dump it all into the logs. That's great. Make sure you don't have any email or any custom information entered in there. That's very important, and we always try to avoid these situations. So let's come back to our crash. After looking a little bit around and trying to look at the stack trace and at the object graph, so what I realized was that in Android there's a class called application, and so actually let me move to that. That's this class. And the contract says there is only one instance of application per process. Like that's one of the first things you learn about Android. And you can put singleton stuff in there. It's going to stay there. So this class is like, okay, very useful, and we use it. But when I looked at the crash, I could see that a new instance had been created because I knew that the crash reporter was installed, but the stack trace. So the crash reporter is the default exception handler that reports the crash. But the stack trace happened before the crash reporting was supposed to be installed. So you're looking at something, you're like, okay, so in the code, what I'm doing is I'm creating my Dagger objects, and then I install the crash reporter, because that's what we did at the time. And then I look at the stack trace, and I realize, wait, how did it report the stack trace? I haven't installed the crash reporter yet. That's weird. So you're like, and you come to the conclusion, well, I guess we have two instances of the application class. It makes no sense. It's not supposed to ever happen. So I did this. Basically, in the application constructor, I created a runtime exception, and then I stored it statically, and just to know where the application instance was created, seeing the stack trace of it, and then whenever it was created a second time, I would throw an exception and wrap one into the other, so that so you can see that's the first part. Creating an exception out of a cause that is the prior exception, and throw that. And this way, I would immediately know, okay, did it happen or not? And as it turns out, it did happen. A weird thing though, we released that code, we didn't see anything happening. We're like, okay, maybe I'm wrong. And the next release, which I had forgotten about that bug at that point, we started seeing this crash happen a lot. And the other one that I showed you previously stopped. So, what is going on here? Yeah, it made me change. Like I was thinking I was crazy, and I was doubting about Android, but that's the rule. It's supposed to work that way. So we looked around. And so when you looked at the crash, you could see that a broadcast receiver was involved. And a broadcast receiver, it's basically a receiver for messages sent by the system. And so we had a broadcast receiver to know when Wi-Fi was turned on and off. And at the time, we didn't disable it when we didn't care, so it was running all the time. And the effect is that as soon as the Wi-Fi, the network changes, your process gets started, and you receive a callback on the receiver telling you, hey, the Wi-Fi changed. So all of the crashes were related to a receiver, one or another, always systematically. So that was an interesting one, especially given that when you look at the contract, there is a contract in the documentation that basically says a receiver will always handle the message, and it's given 10 seconds by the system to do that. And the system will not kill the process, even under memory pressure, until the receiver is done handling the message. So that was interesting. That's our first clue. The second clue is it seems to always happen on updates. And the third thing was the line, I told you at the beginning, the line numbers didn't match the version number. But when we started looking at the history, we realized that the line numbers were always the ones of the previous version number. So I'm not going to spend too much time explaining all these things, but basically what was happening, which is fascinating, is you would start downloading the app, the new update. At the same time, the Wi-Fi changed or something changed. The process was started. But because you're updating the app, the system decides that it's time to shut it off because it's time to update it. So it started doing that, and because you're updating the app, you're moving. So an update is very simple, right? The download manager downloads the new version, the new APK, and it puts it next to the other. The APKs, they always have like name-1 and name-2.apk, and they just switch back and forth every time there's an update. And so what it would do is download the new one, remove the old one, and when it would remove the old one, that would destroy the resources object, and that would destroy the application object. But then the system at the same time received the receiver and say, actually I need to start the receiver. So it would start the receiver. And because it started the receiver, the code actually in Android checks, hey, I'm starting a receiver, I need an application instance. So it would recreate an application instance. And that's where our second instance was created. And so, and then the receiver, we were trying to access resources, but resources were referencing a location that didn't exist anymore because we had downloaded the new one and removed the old file. So it was like, oh, no resources, because I don't know what to do. And then it crashed. And so we tried to report the crash, and we would ask the system, so what's my version number? And the system would, look at the package and read the package and say, well, that's the new version number. But you're running the old code because the old VM is still running. Yeah, so that's pretty much all I wanted to say about this crash. It was kind of crazy. The interesting part was it only happened the proportion of the crash was very high on Android 4 and above and very low before. And that was really strange. And the reason for that is because at that point when we started having Android 4, we had way more phones with multi-core. And so this is a concurrency issue. So as soon as you have multi-core, you have way more chances of things happening like in the wrong order at the wrong time. So to, we're getting to the conclusion slowly, but one of the key things here is how do you get good at fixing crashes? I told you I wish we could interview people and ask them to fix crashes because that's like really important and it shows. But how do you get good at that? I think there's only one main way, and it's reading code. You need to read all the code. So you need to read your code that your colleagues wrote, and then you need to read the Android code, you need to read system code, because that's how you build a comprehensive vision of how your system works. And so that's how you can find the crazy things that are happening. Another thing, once you think you found what is going on exactly and how to fix the bug, it's always useful to run git blame on, not who created the bug, but why was the bug introduced? It's a super important question. Git blame, I don't really like the name because blame makes you think, you want to blame that person. But looking at the commit that introduced the bug is very interesting because it tells you what was trying to be achieved here. And so it will give you more context, and maybe by fixing the bug you are actually introducing another one. So by looking at that you can check that you're not breaking something else. And if someone introduced the bug, you should talk to that person and tell them what you just learned, because it's always interesting to share that knowledge and make everybody get better. So yeah, it's really important that you invest on crashes. You spend the time needed to investigate. We know why now, because our users won't be happy otherwise. It's good to write down what happened exactly and what you think is happening, in Jira or something like that. It's good for history, and also then you can make a talk about it at Devox. So you can use that. And it's important to build dev tools. We've built like a ton of dev tools for our bugs. One of them is when we're in a dev build, whenever it crashes, we have a notification that provides us a way to send an email with all of this information. We also log that to Logcat. And so the idea here's like that email, part of the content. So we provide all the information we've seen before. But the email is actually sent to an automated Jira email that automatically creates a nice Jira, and we pre-formatted the thing so that it looks, great. And we attach a ton of information. We even include a screenshot for that. We don't send those dev crashes to Crashlytics or Bugsnag. The main reason is because the code is constantly changing. That would be really hard to track and really more like a waste of time. So instead, we send these emails. Also, sometimes a crash happens, and you're just writing the code. You just know that you're doing something stupid. You don't want to report. The other thing we have, because we're writing tools for crashes, we need to test those tools. So a good way to test these tools is to generate a crash. So you can see on the UI behind at the bottom, there's like throw and cut error, and that's how we test our a new version of some crash tools. We've also used that. So in our, I don't know if I should say this, in our production app, there is a hidden way. I'm not going to say why, but there is a hidden way to make the app crash. And the reason for that is because we've gotten so good at reporting detailed information about all the state of the app. Sometimes we have a merchant calling us and they don't have crashes, but they have some bug that's really hard to reproduce. And we really don't understand what's going on, and it's very unclear, and there's somewhere at the other, like somewhere else in the United States, you can't go and say, show me your phone. So instead we tell them, let's do something together. Could you do this thing? It's going to crash. It's okay. And then it sends the crash, and then we can look it up, and we have information about everything, like all of the state, and it can help sometime. So that's the fix that we ended up doing. So there is a static method that tells you, basically looking at the application context, if it has resources null, then that means we're in this weird, crazy situation. And we still reported it because I wanted to prove that it worked. So that's the code of the receiver, the magical receivers. They decide they do nothing if we're in this weird situation, and otherwise just execute the normal way. So yeah, the date, the 19th of April 2014, is the day I saw this crash. And so, because someone read the message and told me, hey, there's this thing, apparently you want to know about that. And I was like, yeah, cool, thank you. So it took 2 releases, of course, because of the prior version thing. But yeah, it means I could stop thinking about it. So that's going to be all for now. If you have any questions.
The view hierarchy information, where do you pass that?
So the view hierarchy information, where do I pass that? So most of these frameworks, libraries, they provide, when you report the crash, they provide a way to attach information to it. It's usually in the form of strings. That's actually an interesting one. As of right now, I think Crashlytics only allows you to have unformatted key values. So it's like it ignores return characters. Bugsnag, on the other, on the contrary, has tabs in which you can put any key, any strings, and it's going to respect this, the backslashes and all that. So every time there is a crash, we get that crash, and then we retrieve all the information we want. And then we send all of that with the crash to Bugsnag or Crashlytics. And then this view hierarchy thing, I should probably make, it's a library that we have internally, I should probably release it. It's like one class, but if anyone's interested, I'll do that.
Do you have a library that sends the bug by email?
Do we have a library for the thing that sends the bug by email? No, we don't. So if you want to get inspired on how to do that, Matt Precious and other squares released a library called Telescope, which is it's for bug reporting. So it's the idea that on dev builds you press 2 fingers and it takes a screenshot, and then it does the same thing where you can send a ton of data by email and you can explain what's going on. Really, I don't know if we should make a library for that, because what it is just you send you open the email intent and you attach information to it. That's like supported by Android out of the box. we have plenty of time. You can also leave if you want. We have like 10 minutes. So, yes?
You're no longer using Crashlytics? What's the reason?
Okay, so why did we stop using Crashlytics? I think Crashlytics is a good solution, but I think it's a good solution that's targeting small startups, or let's say more junior developers, or when you don't have the time to think about all that. Because what they provide is stuff that just works out of the box, but as soon as you want to customize what you want to do, it becomes really hard. And when you try to get them to prioritize all of those tiny changes, I mean, we even said, you should open source your stuff and I'll just do the changes that I want. But, you know, we didn't get on the same page on that. So we moved to other things. Yeah. Another thing I didn't say, but obviously Square is hiring. You should definitely apply if you're interested. Okay, well, thank you, and have a great rest of the Vox.
Feeling so fly like a G6.